Hello guys, welcome back. This is Dr. K again. So today I'm going to do a pre-calculus based problem, graphing an absolute value function. So this is the example that I'm going to discuss today. Y equals 2 minus 2 times absolute value of x plus 1. How do we graph this absolute value function? So before doing this, let's look at the most basic absolute value function, which I think all of you know, which is y equals absolute value of x. Okay, so let's see what's going to happen when x equals or greater than 0. So that is this condition. For this condition, you can see the absolute value becomes plus x. And when x is less than 0, for that condition, the absolute value function, it becomes minus x. So this is what we call the piecewise function. This format of the absolute value function is what we call the piecewise function. And here, that's the turning point. Can you see when x is equal to 0 or greater than 0, we have one condition, and when x is less than 0, we have another condition for the y. So that's kind of the turning point. So we are going to use this basic model to solve this problem, to get the answer, what's the graph for this absolute value function. So first, I'm going to look at this one. So absolute value, okay? So I'm going to first write y equals, and then as you can see, when x plus 1 is greater than or equal to 0. So that's the whatever inside the absolute value is greater than or equal to 0. It's similar to this basic function. Whatever inside the absolute value, you take greater than or equal to 0, and you take, in the other condition, it's going to be less than 0. So that's the thing I'm going to do. And you can see this is nothing but x greater than or equal to minus 1. Okay, so when that happens, our function is going to look like this: 2 minus 2 times, remember the positive value, right? So then here we'll just have the positive value. So I'm going to put x plus 1. Okay, so that's our first part of the piecewise function. Can you see? X plus 1 greater than or equal to 0. That means x is greater than or equals to minus 1. And then we are going to look at the second part of our piecewise function. There, just like this one, x greater than 0. Here, x means whatever inside the absolute value. So that's going to be x plus 1 less than 0, or x less than minus 1. So when that condition happens, x is less than 1, we will have 2 minus 2, and look, when x is less than 0, it's minus x, right? So we need to have a minus sign in front of this guy. So I'm going to write it like this so no one is confused: minus x plus 1, and then close parentheses, the square brackets. And that's our absolute value function converted or transformed into its piecewise function form. And you can see here, when x is greater than or equal to minus 1, we have one condition, and when x is less than minus 1, we have another condition. So minus x is kind of the turning point. It's the turning point, okay? Minus 1, that's our turning point. Okay, so we will use this when we graph, okay? So now let's try to simplify this. This is basic algebra. I think everyone can do that. Can you see? You can distribute the minus 2, minus 2x, and then there's another minus 2. That minus 2 cancels with this plus 2. So for the first part, you will get simply minus 2x. And the condition is x greater than or equal to minus 1. Okay, simplified. Can you see that? It's simplified. Now here I have a minus 2 multiplied by this minus x plus 1. That's going to be plus. So I'll have a plus 2x and another plus 2. So that plus 2 plus this guy is going to be 4. Okay, so look carefully. Minus times minus, that's going to be plus. So when you multiply this with x, you get 2x. And then there's a 2 here, which is a plus 2, and another plus 2, that's plus 4. Okay, that's going to be plus 4. And then the condition is x less than minus 1. And look, we have our piecewise function. The absolute value function is converted into its piecewise form. And now we are ready to plot the graph. And keep in mind the turning point. At x equals minus 1, we will have a turning point. So I'm going to sketch. This is not a precise graph. It's just a sketch. That's the y-axis. That's our origin. And then over here we have our x-axis. Okay, so as I told you, turning point is minus 1. When x equals minus 1, let's see what's the y value. So I'm going to use this, right? Because look, there's an equal sign. So when x equals minus 1, what's the y value? Just substitute for this part of our function. So minus 1 times minus 2 is plus 2. So then when x equals minus 1, we will have a point here that's plus 2. That's plus 2. And you can see that's going to be our vertex. That's going to be our vertex. When our x value is larger than or equal to minus 1, so that is on this side, okay, we will have minus 2x as our function. And minus 2 is kind of the slope, right? So we'll have a negative slope, and it's going to be a function with a negative 2 as the slope going through the origin, because there's no y-intercept. So it's going to look like this. Okay, and that's the negative 2x part. Y equals negative 2x part. And then over here, that's a positive 2x plus 4. So that's going to look like this. That's going to be y equals 2x plus 4. That's a positive slope, right? That's a positive slope. That's a negative slope. And if you and we only look for 2x plus 4, we only look when x equals less than 1, when x equals less than 1. So that means on this side, And if you kind of extrapolate this, you will see that is our y-intercept, and here y-intercept is 4. You will get a 4 there. You will get a 4 there. And this is the final graph for that absolute value function. That's the answer, guys. So the graph for this absolute value function, okay, that's this one. That's that one. That's how you do it. And then this is, be mindful, that's going to be a straight line, okay? That's it, guys. That's how you do this problem. I hope you learned something important. Follow me for more of these problems in physics and math, guys. See you later.